Okay, this is module 4. There are 5 problems in this module. As you can see, I've already entered my student number and started problem 1. This is about a chess player who's taking some pain medication, and the question is whether this medication will affect the chess player's performance. The experimental design has to do with whether we're making observations or whether we're interested in a group of subjects or a single subject. Okay, because here we're making multiple observations on a single subject, this is a single subject design, so you just have to type in single subject. Okay, so what constitutes the experimental measure or trial? It has to be a chess match. Winning a chess match is one of the possible outcomes, and the chess player's name, that's not really a trial. Okay, so it's B. Okay, is the outcome of a measurement mutually exclusive and binary? They're not binary because you can win, lose, or draw, so those are 3 outcomes. So the answer is no. The next question is, are the experimental measures or trials independent of one another? Answer yes or no. If we assume the null hypothesis is true, then the probability of success or winning a match or drawing or losing is going to be constant from trial to trial, and there's no reason for us to believe that the outcome of one match will influence the outcome of another match, so that's why they are independent. So the answer is yes. Okay, is the probability of success constant from trial to trial when the null hypothesis is true? Yes, I already said that it was. Specify the probability Janice will win a match if the painkiller has no effect. Here, I just have to look at the window on the left because I don't remember the values, and the answer is right here. It's 0.5. Which of the following statements best characterizes the research hypothesis? Because it says her coach is interested in whether or not the painkiller will affect Janice's game. It doesn't say whether he thinks it's going to make it better or worse. So the answer has to be C, that it will change the likelihood of winning. Okay, so there's the probability distribution. The next question is which of the following rejection regions is appropriate for this? Because it's a two-tailed test, we have 2 rejection regions. That should be easy to see that it's C. For the probability of a type 1 error as close as possible to an alpha 0.05, enter the value of the lower critical value. Here you're starting to add up from the bottom until you get as close to as 0.025 as possible, because remember we're dividing alpha by 2, and because this is a symmetrical distribution, once I find it at the lower end, I just have to count the same number of successes at the top end to get the upper critical value. So let's add here. I'm just entering the values 0.001 plus 0.009 and so on. Okay, so the answer should be 3. Let's hope that's correct. Okay, the upper value, to get the upper value, you just have to go 4 up here, so that's 11. So 11 is the upper critical value. The true probability of a type 1 error would be the cumulative probability at each end added together. So I have here 0.0288, I multiply that by 2, and it's 0.0576. Let's make sure it's rounded to 4 decimal places, and it is. Okay, do we accept or reject the null hypothesis? Again, I don't remember how many matches she won. She won 6 games. Is that high enough or low enough for us to reject? Because the lower critical value is 3, we do not reject the null, so we accept the null. Okay, on to problem 2.